Mine are gone. Made a mistake. Wouldn't download. So for part 2, let's take a look here. We like the standard unit vectors also because it's nice kind of add them. Like let's say we have vector v is the vector 2I plus 3j. And let's say vector w, we'll call it, is negative I minus 3, or let's go minus 4j. Okay? Well, if I want to add them together, like what will be vector v plus vector w, it's just adding them together. So we go 2I plus 3j plus, this becomes negative I minus 4j. And I just combine my like terms. So we get vector v plus vector w equals 2 minus 1, which is just 1I. The j's, we get minus 1j. And so what I'd like you guys to do, see if you can subtract those, see what you get. Please do those, okay? I may not go over all of these, but I will grade them when I look at them, okay? All right, let's go on to part 2, the next page. Now, how do we find magnitude, which is the length of a vector? This just basically comes from right triangles. So if I have a vector, here's my initial point, here's my terminal point. If I'm going up here, I can think right triangles. Remember, this is just delta x. That's just my change in y values. So if I want to find the magnitude of a vector, its length. Now, first of all, to define magnitude, we use a special symbol. It's like two absolute value symbols. Okay? If I want to find the magnitude, I can use Pythagorean theorem. Delta x squared plus delta y squared equals my magnitude, which is the length of this vector, squared. So how do we get the magnitude? Very simple to do. Take the square root of both sides. The square root of x squared plus this delta y squared. And that's how we get magnitude. Just right triangles. So if I want to take a look at number 1, draw the vector. If I start at 0, it's going right 4, up 3. There's my vector. There's 3. There's my right triangle. So if I want to find the magnitude of this vector, Pythagorean theorem, 3 squared or 4 squared plus 3 squared, take the square root of that. Don't be a hero. That's the square root of 16 plus 9, which is the square root of 25, which is just 5. Let's try B. Number 2 here. Draw it out. This time we go left 2. Negative 2, up 5. Starting at the initial, the 0, that's where I terminate. Again, draw your right triangle. It's 5 and negative 2. So to get the magnitude of the vector, it's 2 squared or negative 2 squared, which is 4, plus 5 squared, which is 25, and we take the square root. So the magnitude is the square root of 29. So let's try 3. Now 3 is in our unit form, it's our standard unit form. Easy to graph though, remember. Right 1, down 3. 1, 2, 3. And there's my vector. Draw your right triangle, negative 3, right 1. To get the magnitude of the vector, 1 squared, which is 1, plus this, if you want to write that negative 3 squared, that's okay. So we get the square root of, that's just 1 plus 9, 10. Very easy to do those. All right, now tomorrow we're going to spend a lot more time dealing with direction of a vector. But how do we, we're going to hit that a little bit later on today, but it's not that bad to do. Right now we're going to take a look at how do we find a unit vector. Now a unit vector is any vector that travels in a direction. So I might have a vector. Here's my initial. Here's my terminal. Now this might have a magnitude of, let's say, 5. I want the unit vector. The unit vector will have a magnitude of 1. So even though the whole length is 5, its unit vector, I want to find the unit vector, the part of the vector that only has a magnitude of 1. Okay, and that's what we're looking to find here. So how do we find it? Very easy to do. Very easy to do. All you're going to do is you're going to take your vector, So you can take your vector like if I were to draw this out right here. Let's say this is my delta x, that's my delta y. So my original vector is delta x, comma, delta y. That's my vector. To get the unit vector, we divide each component by its magnitude. So if this is vector v, the unit vector will be the same vector, but we're going to divide by its magnitude. So we just divide by the magnitude. Divide by magnitude. Okay? So let's go and find the unit vectors for the following. So I got to find the magnitude. The magnitude of u. Very easy. If you want to draw it out, you can. 3, 4, there it is. Right triangles, so it's going to be 3 squared, which is 9, plus 4 squared, which is 16. Take the square root of that, we get the square root of 25, which is 5. So to get the unit vector, the unit u, it's going to be 3 over 5, comma, 4 over 5. And this is easy to verify. How do I know that this has a length of 1? Find its magnitude. The magnitude of the unit is 3/5 squared plus 4/5 squared. Square root of that. That's just the square root of 9 over 25 plus 16 over 25, which is 25 over 25, which is 1. There's my unit length. So try 2, and we're going to do number 3. Now 3 is the same thing. I like these. These are kind of easy. And now you can write this in component form if you want to. You don't have to graph it. I can write this in component form. Again, something we're going to take a look at tomorrow, but it's easy. Its change in x is -2. The change in y, 5. So once you get that, now the magnitude of w is pretty easy to get. It's going to be 4 plus 25, squared, squared. So we get the square root of 29. So the unit for w, it's going to be, if you want to write this down, -2 over root 29, comma, 5 over square root of 29. Now your back of your book is going to simplify that, but you don't have to. Or if you want to keep it in the original one, it's going to be -2 over square root of 29 in the I direction plus 5 over square root of 29 in the J direction. Either one's acceptable for us. All right, pause if you need to. All right, now for part 4, it says find the vector v with the given magnitude and in the same direction. That's very easy to do. I want to go in the same direction, so all I really need to do first is just find out the vector for it. Find vector v. That's vector u. I need to find vector v. Okay? So what are we going to do? We got to find out direction. So u isn't going up 2, up to 5. So it's up 2/5. So I kind of want to get its direction, okay, in the same direction. Now that's the key word. I got to get direction. So if I find out its magnitude, I can kind of get like the coordinates for this one right here. Okay, hold on. Direction, what we're going to do is we're going to use a little bit of trig. Now, we have to find its x and y components. So to get that, remember, x is the cosine of the theta, y is the sine of the theta of the angle. So we have, since they both involve the hypotenuse, we got to get the length here. Well, right triangles, that's just 4, 25, that's the square root of 29. So the cosine is going to be adjacent to over square root of 29, and the sine is going to be the height, the opposite, 5 over the square root of 29. So this is vector v. Now, so to get v though, but remember it has a length, so v, it's going to be in this direction, 2 over square root of 29, 5 over the square root of 29. But remember, it had a length, a magnitude of 6. So what I'm going to do is I'm going to multiply this by 6. Now really what we just found here, this is the unit component. I broke it down. The original direction is this. I want its unit component. So this is length 1. This has a length of 1. So now I want to make that length 6. So what I do, I take the unit component, its direction, and multiply it by 6. And that's going to give me, just distribute like in algebra, 12 over the square root of 29, 30 over the square root of 29. And that vector will be length 6, heading in the same direction. All right, go to part 3 if you need to. Well, you need to. Go to part 3.